Hello Internet! In this video we are going to be working on making these projectiles seek a target. So this is a little VR project I've been working on. It allows you to cast spells. In this case it's a magic missile. And then after you charge it you can throw it and it will fire off. The problem is aiming. Aiming is really hard. So what I'd like to do is kind of cast a cone out. And we're probably just going to use dot products for that. And if it finds a target, whichever one is most in line with it, it will target that. And then it will seek towards it. It may not necessarily actually get to it. But the idea is hopefully it's sort of like some aim assist, so you don't have to be totally precise. And it kind of gives them that sort of magical mind-controlled thing. So they're kind of affected afterwards. At least that's the idea. So as you can see, I kind of already have some things going on here. We have a projectile that you can throw and it explodes and does all sorts of fun stuff. It's just a basic particle effect. Yeah, that should be that. Let's see here. So the way this works is there is a projectile speed asset component. And so what this speed does is it has a velocity which is set by the last 3 points of the controller. So what it does is it looks at the two deltas there and then averages them and then uses that as the velocity. And that sort of helps eliminate some of the noise just from tracking and stuff. I've noticed with vibration, like I use to kind of indicate that the channeling of the spell has finished, the Vive kind of gets a little bit of additional noise with its tracking on the controllers. So that smoothing hopefully kind of helps it out a little bit and kind of eliminates some of the precision that it would be required. That was the idea, at least. So all this does is just shoot it out. I can actually open this up because that's going to be really small. But what it does is it starts it out at a constant, at the speed and velocity of whatever you were throwing it at. And so speed and velocity is actually not the velocity. The velocity is actually just the direction it's aiming, and then speed measures how fast it's moving in that direction. And so the way this works is there's actually a target speed. So magic missile, for example, I think I have set to like 10 meters per second. And so you may not throw it at that speed, but if I just go back here, for example, if I go here and drop it, it will kind of go faster, way faster than the controller. You can see it speed up there. And we can kind of tweak how fast that happens. But the idea is it moves at a constant speed, but it kind of accelerates up to it. Or if you throw it really fast, it will decelerate it. And that kind of gets it all smoothly feeling normal. So we can stop that again, jump over here. And this is the script for it. Really simple. This is just detecting if it hits something. And then we have some basic speed stuff. I want to keep this exactly the same. I don't want to touch this at all. So what I'm going to add is a projectile seek. Yeah, we'll do that. And so I think this algorithm should work the way we're going to do this, which is just dot products. This should work for pretty much anything. There's no reason this wouldn't work for, like, if you have a gun, for example, that you just want aim assist on. Say you're working on a console and you need aim assist. This should do that too. I don't know how it's actually implemented on those, but I'd assume it's similar. So the way this is going to work is we're going to have a targeting cone. And I think on draw, if I add some gizmos to this and actually print out this cone, hopefully that actually will show us a little bit more about it. I don't know if this is actually supported. So draw cone. No. The answer is no. We could. How much do I care about this? Because what we could do, let's do maximum angle. And so what we can do is we can actually draw a array. This is going to be kind of hard because we're going to have to do some matrix transformation because we want to take effectively I'm going to draw a cone on the z, going along the z-axis, along the forward axis, and then I'm going to transform it into the object space. And so effectively what that looks like is we are going to have, everything is going to be origin this transform dot position, just origin right at the center, and then we are going to actually move it forward. So it's actually going to be a vector3 dot, we don't actually need that because let's have this be length 1, so mathf dot, that's not going to work, new vector3, there we go. Let's start with the basics. And then if we do it along the x-axis, so along the plane here, x-axis, everything is going to be on the z, and then along the x, yes. So this will be our sine, mathf sine of our maximum angle, and this can be just the positive and the negative of that, and that should work. So we'll get that. Y we don't care, that's going to be our cosine. And then z is actually also going to be cosine? Yeah, cosine will work, I think. Pretty sure. I'm like 95% sure this is correct. I could be flipping this backwards, and then that's not going to work very well, but oh well. And actually that's array, so that won't work, but whatever. It's not going to work because we have our ray casting in some random direction. It's just going to be along the z-axis. So let's just do 0 here. Okay. I would very much prefer if you didn't do all of whatever that was. There we go. Then let's drop those and make one of those negative. Cool. So theoretically this does what we want. Let's make it dot color. Let's set the color equal to green. Let's do blue. Sure. And so we are not going to put that on anything. We're going to just stick that here. Projectile seek. And stick it on the game object. And we get that wonderful thing. And so right now, everything is just, all 4 of those lines are just drawn on top. But as I move this, they should spread out. And then as I get to about half of pi, so 1.56-ish, it should be almost like that. And yeah, so those are arrays. Obviously, as I rotate this, nothing happens. So that's the next thing we need to do. This is mostly just debugging stuff, but it's going to make actually understanding what's going on a little bit easier. So that's why we're spending this time on it. So I think this should work. Let's just do this transform and let's get a world to local matrix. Actually, let's get a local to world matrix. So we're going to take this, we're taking this vector in local space and we're translating it into world space. So if we multiply this, these should now be in world space, so they should be relative to the object. So after this compiles, there we go, I think, maybe? Yeah, so now it actually rotates. And so this way, our object, our cone, is actually drawn along the z-axis, the forward axis of this model. But as we update it, as we rotate this, all of that z-axis, that forward, is translated into our current world orientation. So as we move this around, and actually as we scale this, it should scale as well. So if that's something you need, that's there. But it's going to be based entirely off of whatever that transformation is. So everything should work. We should be able to rotate it and do everything. And it should perfectly match the forward axis. So cool, that works. Now, we need to actually do something with this ray. So, what's the best way to do this? I think, if I remember, I don't, so this is going to be a little bit of an interesting position, but we are going to attempt to find the best target. So I'm going to do public transform, and we're going to save just a target. That's public, not for any real reason, just so that I know that it's there. And then, ooh, where did all of these come from? So I've imported a number of projects, so I'm getting a bunch of random tags from other things. That's interesting. I don't need any of those. I'll have to clean that up. This is mostly just a test bed, but what's the best way to... I'm trying to figure out how... We need a way to actually find targets. So I want to either... We've got players. I could track players. What do we want? Projectiles? No. Let's do seekable target. Sure. And so this, we're going to actually open this up and say public string target tag, and we'll just set that equal to seekable target, just hard code it in. This way we can change it if we need to, if for whatever reason we need to change that, but otherwise it's just going to find one. I'm just going to put in like a target, and we can throw at things and it should move towards it. So we've got our maximum angle. Let's not worry about like how fast this is going to actually seek towards it. That's all we need right now. Let's actually add a projectile. So this will be our projectile speed. And all of this is just public now, mostly for my benefit, not because it's needed. And then let's say target equals find best target. Yeah, so this should work. And so this method is going to actually find the seekable target that has the least angle that is within our cone. And we might be able to do a maximum, we might want a maximum distance too. So if I do public float maximum distance, for what I'm making, it doesn't really matter, but if you're doing something else, it might make a little bit more sense. Yeah, we'll keep it in there. It's not that actually. I'm going to take it out. It's just additional work. It's not really any added feature. The same checks that we're using to limit the maximum angle can be used to limit the maximum distance or any other criteria. So there's actually no reason to do that. So we're going to skip it. Instead, I'm going to do find objects. We need game object. Find game objects with tag. And so we are going to find everything with a target tag. Ooh, that's not how you spell that. There we go. And then I want to sort them. Order by. So we're going to sort this entire list of game objects by their dot product. And then we're only going to take the ones that have a dot product greater than a certain amount. I'm going to use link here this is not going to be the most efficient path. There are going to be better ways to solve this, but I think this will just be a little bit more explanative, and we can get it better if we need to. Text, what am I doing? So target. So we're going to order by the targets, transform position. That's not how that works. We want to do a vector3 dot dot of this transform position minus the target's transform position. So this will be world space difference between those two. And then we also want this dot transform dot forward. And so this is going to return us the angle of difference between these two. It's actually arc cosine, I believe. I want to say it's the arc cosine because for normalized vectors, this will be between 1 and -1. And then zeros will be perfectly on the sides, which makes me think, yeah, arc cosine sounds correct. Don't quote me on that. Let's see here. Dot product, yes, I want this normalized. Like I was saying, this works with normalized vectors best. And so we get that. Cool. The inefficiency comes in here because I'm going to actually order by only where our targets. So what I've done now is I have a list ordered by the dot products, and it should be ordered by, we want to be descending, which means that the higher values, the ones that are most in line, will come out first. And then everything after that will come out last. And so I want to take them ordered by that where this dot product is greater than our maximum angle. And so that thing about arc cosines, we're going to actually plug that in. So we're going to plug that into our arc cosine, which gets us a float, which we then compare with our maximum angle. There we go. And then I want the first result. Ooh. This is getting a little bit out of hand, but okay. I don't think that made it any easier to read. There we go. It really doesn't like that. With single call to first or default. How are you going to do that exactly? Oh, so you can just, okay, got it. So what it did is it removed the where and just used that as a predicate for the first or default, which is perfectly fine. It's the same thing. And so this will just search over the list item by item. It will first sort it, and then it will go through and find whichever one is the most in line that also matches this predicate, and then return it. If it doesn't find anything, the default value for a game object is going to be null. So if we get null, we know we didn't find any targets, and then we don't have to do anything. So this will be our, we can actually just return this because we'll get, we can't return that. Sorry. Actually, no, we can't. Yeah. This will be our target. Cool. Can't call it the target. That's probably a bad idea. Let's call this the found target. I guess that makes more sense. So if the found target is not null, actually, is there, yeah, because we need the transform out of this, not the game object. So let's return, if it's not null, let's return its transform. Otherwise, we will return null. So we didn't find anything. We're just going to return back nothing and expect whoever is actually working with this to handle it somehow. So this might be a bad idea, but I'm going to actually call start from our update. We're never going to actually run this, but I'm going to also put it as an execute and edit mode, which means this should now find things as we move them. And so as I create a sphere, kind of move it out that way, give it the seekable target tag, and it's very, hopefully, obviously, inside of that. Now as I rotate this, well, let's do along the Y, it should update. Or not. And I have no idea if that's because I screwed something up or because I'm testing this in the worst way possible. We should definitely take some time to look at the new testing tools in Unity, because that would be the correct way to do this. Not this. Let's do like 0.3. I'm still expecting it to be greater, and it's not. So why is our target wrong? That's the question we need to solve. And I think it has to do with this predicate being wrong. But I'm not sure. Let me do some research on the dot product just to confirm that arc cosine is correct. I'm almost positive that it is, but just to be sure, I would like to confirm that. Maximum angle. That might be part of it. It has to be less than the maximum angle, right? Yeah, that's definitely true. It should definitely be less than the maximum angle. So let's see if this actually changes anything. I don't think it will. And it doesn't appear to have. I'm going to attach a debugger to Unity. We're going to see what happens. This should be triggered almost immediately. Unless it isn't. This is unique. So we're taking our angle, comparing it to, we actually want to flip these. That's part of the problem. So we want to take 2 points. If this is the target and this is our player, I want a vector that aims towards the target, which if I'm taking the current position and subtracting the target, we'll get a vector going that way. We want it the opposite direction. So let's take our target and subtract off the player, like so. It should also totally reverse our ordering, which would have been great. All right. Come on. Compilation takes so long. There. Okay, we found it. And now we don't. Awesome. So it's working now. Great. Didn't even need to do that verification. Everything is fantastic. Awesome. So now that we have all of this, we still have not done anything for actually seeking our projectile. So that's the next thing we need to do. We need to actually make this pull our object towards whatever it is we're seeking. So there's a number of ways to do that. We could do basic steering stuff, or we could just like take the two vectors and average them and just keep doing that over and over again, and it would eventually get there. there's a number of ways we could do it. I don't really know what the best way is, but we're gonna try a few, I think, or one, and then maybe pick it up later when that one doesn't work. But anyway, what we need is we have this projectile speed. First off, if we found a target, actually if our target is just there. So shorthand, we're going to leave off that null check. If the target is there, then the projectile speed dot. So we have speed and velocity. Velocity is going to be the normalized vector towards whatever we're going towards. So that normalization was what I was talking about first. So let's just really quickly do that. This is kind of like a LERP, but it's not really a LERP. Actually, a LERP would work. We could do that. But yeah, let's do that. That'll be better. So vector3.lerp, and this is just going to slowly move something towards another vector or towards another value. So you give it one value and another value and a float between them, and it finds the middle point between them. The alternative to LERP, which is a linear interpolation, is a Slerp, which uses spherical interpolation, which is useful for like rotations, which that should be kind of leading. You should kind of get the idea there. But we're going to start with a LERP, and then I think we can do a Slerp, and everything should just work. But there's going to be a few. Hopefully the difference is noticeable. It might not be, but it definitely, if you try to use a Slerp and you're like moving something, it's really not going to work for you. It's going to look pretty funny. I would recommend trying it. It's interesting. So we have this projectile speed. The next thing, I know my target exists, so I'm going to take its position, and we're trying to get a vector towards it, so we're going to subtract off our position and then normalize that. So let's do that. So we have two normalized vectors, and then I want to take the maximum angle. Why would I want to take the maximum angle? Let's take the time delta. That makes a lot more sense. And then we're going to normalize this vector because it isn't necessarily going to be normalized. Because it's a LERP, it's effectively taking 2 points on a 2 points on a normalized sphere, and then drawing a line between them and kind of connecting them that way. Whereas a Slerp, it would take 2 points on a circle or on a sphere, and then move around the circle to get to them. So if you're thinking about it like Earth, I guess if you are driving around it, you're slurping-ish, sort of, if you think of that as like a rotation. But if you're like drilling through the Earth, that's more of what a LERP is going to do. So I guess if you want to get out your drill, then this works. But it'll be similar, but not the same. So velocity equals that. It's going to be totally based off of the time delta. That's fine. But hopefully, well, first, this isn't going to work at all because I did not connect the projectile to the actual missile. That would be key. So let's remove that. Let's pretend like that doesn't exist for now. Let's grab our magic missile. Where did I put you? In here. All right. And then we'll do a projectile seek with a maximum angle of, I don't think 30 is correct because I'm pretty sure these are in radians, so let's do like 0.5. Yeah. And then projectile speed, hook that up. Seekable target, that's all good. I'm just going to add this to the scene so we can kind of inspect it and make sure it looks correct. this cone is actually going to be pretty helpful there. And then, yeah, I think that looks good. So 0.5, maybe 0.3. For testing, let's do 1. I know, I changed my mind a bunch, but it'll just be easier because I don't entirely know how this is going to go. So there is our target. It's hard to hold this, but obviously we have overlooked something. I hope you guys can't hear that rumbling. It's kind of, yeah, we'll see. Why didn't that work? Oh, wait, hold on. Did I do something silly? I may have done something silly. Nope. We've got the delta. It's based off of the velocity, so that's good. That actually makes sense. Then what have I missed? Why isn't our velocity changing? Unless, hold on, I may have screwed this up. We are going to take void awake. I'm going to actually point this towards where we're throwing because currently that doesn't actually happen. Everything is kind of, it doesn't matter because it's just got the velocity. We're going to actually make this look forward. And so the best way to do that is to do something like this, transform rotation, returning look rotation, and then it just expects a forward vector, so we can just do velocity and give it, I guess, a normalized velocity. This isn't great. We could probably fix this a number of ways. Like I could pull all this stuff out, move it up here, delete that, and then actually use our velocity instead because it's already been normalized. We don't need to do that twice. So hopefully that's a little bit better. So now, hopefully, it actually is facing the correct direction. What would have happened is everything would have been facing down our field, which means everything would have been out of the lock-on range. Yeah, it works. So you may have noticed it still missed, obviously, but it did track a little bit, and it will continue to track as that one just did. So it should loop around. You can see it kind of curving way off in the background there, and then it should come back. This one might kind of go up, but it has locked on. They may live a little bit too long, but you get the idea. We can actually track, and it's not super aim assist, but it's enough to kind of give it that magical arc. And you can kind of like throw them up, and then they arc down and do whatever, which is cool. It's a simple way to kind of make it more easy, I guess, especially since this is like the basic spell of the game. And it's no fun if you can't hit anything. Obviously, there will be precision things, at least in what I'm planning. But it's nice to have some things that don't miss as easily, especially when you need it to play the game. So yeah, that's seeking missile projectile things. That's one way to do it. We are using a LERP. Before I do anything else, let's actually plug in the Slerp. Shouldn't need to change anything else. It's just taking two rotational vectors and doing, like, I guess that's a good example of it. It's instead of connecting them like that, this is a bad example, but instead of connecting them through, like drawing a straight line between the two, it's doing an arc. So hopefully that speeds or makes it a little bit more realistic, doesn't have some random acceleration or anything in it. Not that I think it would, but yeah, this is just the correct way. And so there we go. And it does appear to actually turn a little bit better. That might be just my imagination, but yeah, no, that seems more correct. Cool. That actually looks really sweet. I like that. Awesome. Okay, I'm going to go play around with this a bunch, but I'm going to leave this video here. It's sort of a really basic demonstration of how to get things to kind of follow one another, and also kind of covers a little bit more about dot products. I don't know, I use those all the time. They're super fun. Fun is maybe not the correct word, but they're super interesting. They can do so much. So yeah, that's it for this video. I hope you guys learned as much as I did, because I had never done this before. So if there's anything you guys want to see, any suggestions you have, any criticism or ways I can improve, let me know in the comments. But till next time, see you, Internet.